Okay, today I'm going to continue working on my code generator. And last time we got very, very simple code that could produce very, very simple code from very, very simple code. Figure out what that means. It looked like this. So this is taking a super minimal live coding language definition and outputting this snippet of valid Rust, which produces a DSP graph that is the same DSP graph as my my source, which looks like this. So this stuff, just like one sine wave generator with a constant input. So that's pretty exciting. It's not much, but it is thrilling as these things are. So today I'm going to try and be a little more ambitious. Specifically, I want to do modulation, and by modulation I mean that. This is the most basic thing that's more complicated than what I had before. So now I have two constants routed to an anonymous node that will contain the output of adding those two constants together, and then that is routed into the sine wave. So my current thing can't handle that. Actually, I think it's going to panic, yeah. And okay, but it gets what you'd expect. So this is a dump of the intermediary representation that it parsed that into. So it has, its final output node of type sine. It has the anonymous node of type add, and then two constants with 220 and 1 in them, and then some edges to stitch all that together. And then it sees that stuff and then blows up. So let's make it not blow up. Okay, actually, out of curiosity, what did it blow up on? That, which is if a thing has more than one input, which the addition node will indeed have more than one input. So that makes sense. So let's start there. So what do I do if I have a node with multiple inputs? This is my case where the sine wave has one input, but the addition operator has two, and so I need to handle that. So what does that look like? This is where I need to think about the port numbers, because in the dynamic version, those determine like which index into the array that is used as an input this stuff goes into. But in the static version, it's more complicated than that, because but it doesn't need to be more complicated. So I made this decision last time that I was going to let's see where, and I had that, where I was going to have the ability to branch, to basically construct that array with multiple elements, this way. Okay, and that's what I need. I think I said I was going to do that between videos last time, but I changed my mind. I'm going to do it now because I need that. And look for, oops, that's not what I wanted. Okay, So due to the way that my code used to be structured, where everything was pairs, and the pairs could be nested into trees. So like every input to every node was a tree of input values, where is a binary tree of input values, and it's just because it was easy to define the value structures that I needed that way. But now I flattened that, and the input to every node is an array, and of node length, and that means that this thing, this branch, which previously was used to take one input, run it through multiple nodes, and output multiple outputs, one for each node. But it could only do 2 nodes. Now I can do any number of nodes, and that makes sense, and it's going to make writing this code convenient. So let's just fix that. So that means that but this is a little bit inconvenient because the previous version, like the generics here, A and B, are the 2 nodes that this is going to be using, and they're heterogeneous. They can be of any type, which means I don't have to box them or anything, because boxing stuff is hard, and it makes this inconvenient. But if I do this without that, then I need a homogeneous array, which means it's going to have to be something like a vec of boxes of type nodes, and they will all have to have the same input size, because I'm going to split the input and duplicate it across all of them. And I don't actually care about the outputs. I think I can do this. And this is going to have a more complicated type because it needs to be this. Want to specify the output. Because I want the output to be able to vary. Because previously what I was doing is like if one of the nodes in the branch output 2 outputs and the other one output 1 output, I would just concatenate those together and it would make a total of 3 outputs. But since to make these homogeneous, I need to put some type here. And the question is what? Because I don't want it to be the same for all of them. This is not a problem that I had considered. If I And so what if I say they do all have to be the same? I think in practice this doesn't actually work as a long-term thing, but it might just get me moving. So now I have 1 input type and 1 output type, which is that's a really limiting constraint on the output type side. But I think it will make that type sensible. Yeah. Okay, and now this is different. But now it's probably still needs C and D. But these are now no longer nodes, they are array lengths. Oh. No, crap, I can't do this. I cannot do this because I need to know at compile time how many outputs I have, and I cannot know that if I have a runtime container here. So this I need a compile time container. Oh, okay. That is not super great. So the compile time container I've been using elsewhere is tuples. And so I could do that. I could say, let's just roll back all of this and go back to what I had before. So if I were going to say have a bunch of these, so say this is a 2-arity branch, and then I could have a 3-arity branch that looked like this. And at this point, I would write a macro to construct these, and I would just construct, from 2 to 20 or however many it makes sense. And then I can know all of this stuff at compile time like I need to, and my branches are just tuples. I think that's what I have to do. Okay, that's fine. Not a big deal. Is it fine? It is. Yeah, it's fine. Okay, so let's write a macro. What does that look like? I need macro rules. I always struggle with this. I've done it enough times that I should remember how it works. So all it cares about is the arity, which is going to be a number. How do I do this? Okay, I don't know. I'm sure there's a more elegant way to write this macro, but I'm going to write the thing I know how to make work, and then if anyone who actually knows Rust ever watches this, they can yell at me. So I'm going to do a num every time I have to look up the syntax. $, variable name, type. $, and then it's going to be an expression. It's PR. And then we're going to have a a list of generic parameters, whatever. Those are going to be IDs, ident, I think. I have to concatenate. Can I just do this with tuples? If I make branch a trait, then I can define this over tuples. Does it actually make it simpler? I don't have to make up a name. I don't know that actually makes it simpler. That is the thing. It is, yeah. Okay. And then I'm going to have to do concatenate to make my thing, and that's going to be once is branch num. And then I'm going to just repeat this. Ooh, no. And the attribute over and over. Okay. And this is that's just a straight string in place, right? Yeah. And then in here I have excuse me. I'm gonna have all of my parameter names. And they're all clone. Like that, okay. And then again. And this time comma separated. That time also comma separated. I think no. I think that works. Okay. Okay. Worser and worser. Because I need these other types to contain the some little things. Maybe I only ever need the two. I need one for the input and outputs. C is the output. That is adding the output of A to the output of B. The output of A is C. So I need some way to get that bound on there. And there's gonna be so many parameters. I don't know if this is gonna work. Okay, I gotta think about this. I'm gonna stop for a second. Okay, having had my dinner and thought about this some more, I'm not going to try and do this. It is too complicated. I'm going to go back to the pair-by-pair version that I had initially, and just build trees. And I think that is the right thing to do. So let's get that one back, all this stuff out. Okay. Now I have undone however many previous minutes of work, and am back to where I was. Okay. But that means I need to figure out how to build the tree here. Not there. Okay. So let me remember what I was doing. So I have this case when there's just one. So if there's more than one, if there's zero, which is the case for some things, I don't know, I'm not sure what that means. But if there's, well, I guess I don't know what that means. No, there can't be zero. I really want there to be able to be zero. Okay, I need to change this. So basically, I want, excuse me, even if something has no inputs, as is the case with some nodes, I want it to appear in my list. And please don't do that. Okay. And in order to make that happen, I'm just going to do that, and I think that's fine. No, that's not fine. Because is this name. I'm going to do the same thing here. So that will guarantee that they're in my edges list, even though they may not actually have any inputs. And then I can do my logic on them. But like if they do have inputs already recorded, this is just a no-op. It doesn't do anything. So cool. Okay. So now I do have this case where it's empty. So let's make that branch because I think that was relatively simple. So if sources is empty, and I need to do something. And what do I need to do? Well, before I think too hard about that, let's go to my example. And how do I make that happen? What has no inputs? Constant has no inputs. But I'm already dealing with constants. So these guys have no inputs. And yet, I am generating code that produces them. So what does that mean? That means that this thing actually this is I'm trying to do this iteratively, but like it's really a recursive thing. Like I want to go into a node, go into all the sources for that node, and in each of those like build that tree up. So maybe I'm just thinking about this wrong. Like I'm trying to iterate, and I'm sure it is provable that there is an iterable, a non-recursive solution, but to any recursive problem. But I think the recursive form may be just the simpler version of it. So what does that mean? What does that imply? So if I did the recursive version, what would that look like? I would go, I would, instead of walking edges, I would walk nodes. I know I have one entry in my edges list for every node, so maybe that doesn't make sense. So instead of, how about this? So instead of filling my edges with these tuples, I have one enum, and it's going to be an edge. It's going to have two branches, two variants. One of them is unresolved, and it looks just like this tuple. So I'm going to name things because I'm going to start getting confused. It's got a destination port, which is a usize. It's got a source node, which is a string. And it's got a source port, which is a usize. Okay, so that's the equivalent of what I've got here. So what I'm going to do is I'm going to take this, and instead of that, I'm going to go edge unresolved. Okay. I'm just gonna build that. Okay. I'm not gonna try and be careful about this cloning stuff because this is only gonna happen, once. And it's going to happen at compile time, so don't care. And these graphs will never be particularly large. That's the wrong one. What is that about that? Okay, whatever. You can be U32. Okay. I apologize for that confusion. Okay. There we go. Still don't need this. Do need that. Wrote the message the first time. Okay. Now you're the one who needs to be cloned. There we go. That is okay, cool. So now my other branch is that this is resolved. And what resolved means is that I have a string that represents code that I can emit into a file, and that code will be the equivalent of whatever this edge is. I think that's reasonable. So like that. Okay. That's good. And so okay. So now what does that mean? What that means is I want to walk through these things, and what I want is I want to walk through every node that has no incoming edges, and it can just instantly be turned into a resolve node. Because we just know how to do that. It's a constant, or it's something else that doesn't have any inputs. Or it has need to look up. It has edges which are unresolved or not. So let's just do that. So so I pop something off the edges, and I'm going to go. Let's see. This is going to be back. Need to get these in order somehow. Come back to that. Just try to back. And I'm going to go for source and sources. So this may be empty, so I may not loop at all. But if I do, I'm going to go. Yeah. So here's my recursion, and so I want this to be inside the function. So I'm going to go. Edge. And resolve edge takes a destination node. I want to be able to pop. Yeah, I think that's right. So I take a destination node, which is a string, and a sources, which is a vec of edges, edge, and those I have just popped out of the list, and then it's going to return a edge which I know to be resolved. Okay. I think this is right. So I'm gonna move this up here just to make it clear what I'm doing. Okay. Okay. So now for every source and sources, and also it needs a reference to edges. I think this is going to work. Edges name root of a hash map of a string to a vec of edge. I think that's the right type. Okay. Okay. And then for each of these sources, they are either already resolved or they're not. So we need to know which case we're in. So so if they're resolved, right now I don't care what they resolve to. I'm just going to stuff them in resolved edges. Resolved edges needs one additional piece of information it doesn't have. It needs this as well. So it needs to know what the code is to produce the output that this thing cares about, and then it needs to know where in the argument list of its parent it should appear, basically. So you just, that is that. If it's unresolved, then I need to resolve it, and I do that by okay, so this needs to take an unresolved edge. No. has a source node as one of its fields. Which means I need to no, sorry. I need to edges dot remove, I think. Remove source node. And that's going to give me it's going to give me a destination node and sources. And just like I got in my list in my iterator earlier, and then I'm going to unwrap that. Again, if this is wrong, you know, my intermediary representation is wrong. That's a code error, and this should panic. Maybe with a better error message, but still, because that is unrecoverable. Okay, so now I have the thing that needs to be resolved, I think. In which case I can go and recurse. I have the sneaking suspicion there's going to be some sort of lifetime problem here, but we'll find that out. Okay, so now once I've done that loop, I know that I have a list of all the edges that are inputs to this node, to the destination node of this edge, and I then can work on them. You know what? This is going to be simpler if I actually go this, not have this actually in the enum. I think it's just going to make the code simpler. And then what I'm going to do is I'm going to return this, and then I don't have to do any matching or anything because I can know that that is a result edge. And that part already works. Okay. Okay, so now I have these resolved edges. And what I need to do is I need to sort that list to get them into the parameter order, the right parameter order. So we're going to resolve edges that sorts by, I think that's right. And the thing we called about set is the destination port. And that will be in with, you know, port 0 is 0, port 1 is 1, so that'll sort in the right order. I think. Sort by keys. I'm just returning the wrong type. Okay. Cool. Okay. And now I need, because I know I've been sloppy about error handling thus far, but this is a mistake that I know is going to happen in code a lot, and I need to handle it. So what if I don't have something for every port? In the live coding language, that is handled basically by just having a default value that gets fed into the ports, and I guess I can do the same thing here because that will give me the same behavior. So I'm not going to fail. Instead, I'm going to fill things in with the default. So how do I do that? I go I need to loop through this list while also modifying it. No. I can do it this way. to basically do a set difference between what I expect and what I actually have. How do I know what I expect? I don't. I need to know the class. To know what I expect, I need to know the type of the node that I'm going to build the code for, but I am like deep in metaprogramming land. And I don't I do have that information. I have it here. This function returns constructs this type. So I can call that function returns a boxed node which has a length on it. Okay. I don't know if this is the best way of doing it, but it's a thing that I can do without doing a lot of work elsewhere. Okay. So I'm going to make the assumption that my nodes are not expensive to construct, which in every case is basically true. So thus far, I have not written a node where I'm worried about the cost of constructing it, even if I end up doing that, like, over and over again. Okay. So here, well, I'm probably actually going to replace all this code anyway, but just for kicks, don't care about that. Okay. So now what I'm going to do is I'm going to go for the node. I'm going to make a temporary node. I could also get the output or whatever. I'm going to go let input port count, and just to hammer home that this is temporary, I'm going to stick it in a scope. So I'm going to look it up in the module constructor. I'm looking it up by destination node type. I need type. Type, which is in my nodes thing, so I need this, and then once I've got that, I can do this. And then that's a tuple. The second value is the constructor, which I can call. Can't capture. Pass this in, that's fine. I mean, I could do this in advance and annotate all this, but that's probably a cleaner thing to do, just for now. These are, what is the type of this thing? It's going to be, I don't want to name the type. Static stir, and a tuple of these functions, whatever they're called. And then a optional string. No, not an optional string. A non-optional static string. Okay. Okay. imported. Okay. Ugh, another one of these things. Nodes, and nodes is a hash map of string to string option node. Function designed here. Okay, that's still fine. Mismatch type expected. Need a bunch more arguments. They are constructors. Mismatch type expected. Something on string. Like this. Expected structure found. Oh, whatever. Okay, so let's see. This is thing into expected reference to something found string. Consider borrowing here. Expected function found static string. Oh, because the function is 0. Fine. Consider borrowing here. Borrow string. Oh, good lord, what are you expecting? What did I say this was? This is a hash map. So you're the string and stir are always, I don't know, I should know how to map back and forth, but it's totally the same thing probably. Okay, cool. I am still uncertain what's going on here. Mismatch type, expected struct, back edges, found tuple, edges, right, yeah, because this is not what this is. So I know that it is unresolved. Wait, no, what am I doing? I'm very confusing myself. Unresolved edge. The thing I'm resolving is this unresolved edge. But I need to know source. I need to know the destination node, sources, edges. Okay. Sources, source node. Okay. What am I doing? Okay. So this is, it is the edge in that, and so I need to go, I do need to go up one, okay. And no, what have I done here? Sources. Okay, this is not right. That's how I got myself confused. The sources are, no, they are edges. Sorry, I'm having trouble wrapping my head around this. Not that it's particularly complicated, just that I hit some sort of mental block. And then it's because the thing that this edge represents will also appear in this list. It will appear in this list. Okay, so I need, this type is wrong somehow. What do I need to be able to do? I need to be able to look up something and okay, so I've got a constraint, and I think this is what I'm wrapped around. The constraint is that I am currently not trying to handle the case where I have the same source pointed to multiple nodes. That's the case I'm going to have to handle eventually, but there's a thing I have to do to make that happen that I'm just not going to try and do in this case. So what this means is that I've got this node, each node in this map should only ever appear in one of these lists. Right, okay. And if it appears in multiple lists or multiple times in a list, then that's an error. Okay, so then from that perspective, what I'm doing here makes sense. I'm getting the one version that appears in the list, I'm removing it. But I need to, and I know that now I think there's a case where it might already be resolved. No. Maybe I may have to sort this before I work, because there's a, if I work from the root of the tree out, then this is fine, because I'm going to hit the leaves, which are the things with no inputs last, or at least I'll hit them after I hit their parent. But in this case, if I'm just picking and if I'm picking random nodes and trying to do this recursive resolution on them, then I'm going to run into this problem where I may have already picked a node to resolve, but then yeah, okay. Okay, so I think I just have to put them back into the list when I'm done. I hadn't really thought about what I was going to do at the end. And I just keep doing that until there's only one left. Yeah, okay. I think that's right. We'll see. In which case, I actually have two cases here, which is why this is confusing. There's the case where this edge has already been resolved previously. Let's see if this is a match what I want here. At least I need. Okay, so if this has already been resolved, and now I do match, and if it is okay, so if it is resolved, then I'm going to unpack the resolved edge from it. Okay, this is confusing because I think really this structure should be no, because this is giving me a list of edges, not a potentially resolved edge. Okay, so I've put this in the wrong place. So this is the resolved edge actually is more complicated than this. It is the unresolved edge is more complicated than this. Because it is this whole list. Then it is this whole list. I think that's right. So let's see, let's make another struct. And it looks like this. And an unresolved edge is actually a whole slew of these things. And then I don't know. I still need this default case, or the whatever, that thing. It's not that. No, it's not the vec that I'm doing. It's an empty unresolved edge. So edge. No, can't do that. Yes, I can. this. No. It's again. Not sure quite why I'm so struggling so much with this. Okay. That is what I want. Alright. And then, here we, what's this going to be? This thing. No, wait, what? This didn't help me. Yes, it did. Yes, it did. Still good. And then push that into the interior container. Because you are now okay. I think this is no. It will never be resolved at this point. Okay. Having the leave X was right in the first place, but then I need to go and remap. So what's gonna happen is I'm gonna fill these guys with these unresolved things, with these what will become unresolved edges, and then I'm gonna convert them into edges afterwards. Okay. Now that's should be no still. Yep, that's right. Okay. Now I'm gonna go edge. I have to change. Its type. So edges. Whatever. And then I'm gonna go. Oh, how do I map values? I don't remember. Edges dot consider, can I do that? Map. Key value. Key stays the same, but the value becomes an edge unresolved with that same contents. And then I collect. So I just changed the type of this. Connected. Okay. All right. Okay, now I can go back to this. So now I have my edges as a different type. It is type edge. Done. And then the node that I am resolving is going to be represented by a string and an edge, because I've removed it from the list. Okay, and then I'm going to call this to make sure I have all the types right. Edge. I think I'm down below where I've already popped it is where I'm actually going to do this, but I'm going to write it here where I can see what I'm doing. Because my screen is so small. And then sources. And nodes. Okay. And then that's going to go here. And this is okay. And that's going to get sad if I've got the wrong type. Wait, what? How is that? I'm not closing this properly, I think. Yes, I'm not. Okay. Okay, whatever. I'll do that test in a second. So, so now I don't have sources. That's not a thing. What I have is either this edge is already resolved, in which case this is a trivial case. I go if so if I can unpack it into that, then I'm done. I just return that. Otherwise, I'm in the case where it's unresolved, and then I have to do work. Okay. And in this world, I now have a wait, can I? Yeah, whatever. Let's edge. No. Not that. That. Otherwise, this is let edge. No, some. Not that. I just want this to. I should go take a nap or something. And in this case, I just return resolved. Okay. Is unresolved. And then now I do stuff. Okay. Oh no. Okay. And in this world, I am okay. So now, my unresolved edge. It is not. That is not what it is. It is unresolved sources. Yeah. In fact, let's just call them sources. Okay. Okay. So now I do have this thing I can loop over, and. Just because the end is not right. Okay, so then now I have these sources, each of which is an unresolved edge of its own. So it is not an edge. It is. So I don't need this because that's just not a thing. I do need some version of this. Okay. source node, destination port, source node, source port. Okay, now I'm in this case where it might be resolved. Handle that. Or it might be unresolved. In which case I need to handle that. So. Okay. And then I resolve the edge by giving it the source node. That's what I'm actually looking up here. And sources and all my other stuff. I'm missing some data there, but that's just not gonna worry about it right now. Okay, and so here, what was I doing? I was calling my module constructor, fine, and this isn't going on. I'm just going to turn something so the lint shuts up. Still unhappy about that. Why? This is not closed. Not closed. This is in the wrong place. Okay, there we go. That's now the error I'm expecting. And what is this? Mismatch type expected unknown edge and a VEC of unresolved edges. Because what I need is, don't care, you get cool. Now I get that untangled. Okay, now I've called my thing, and in has a input len, which tells me how many input ports it has. And I super does needs that thing. Okay. What? No, did I not just do that? okay, so now I know how many input ports I should have. And now is the point where I can do this set difference on how many import ports I actually have, and then insert the missing ones. So actually do that with a set. No, that's too complicated. I don't actually need that. Because these are going to be short, and it's just easier to iterate. So let's see. So I'm going to. No, I am going to do this. Okay, so the set starts with all the ports it needs. And it's going to be 0 to input count. Okay, so I build that set, and then I'm going to go for p in images. I'm going to go this needs to be mutable. Okay. Doesn't matter which one I'm using here. Okay, so now that set contains all of the ports that I don't have, so I need to insert those. And so I go for p in needed ports. I'm just going to make up a resolved edge. Resolved edge, which is a DST port E, and the code is going to be constant 0. Okay. Cool. This has to be a string. And this. Probably just make that a U size everywhere, but. Okay. And you are sad. Why are you sad? Because that was that. Okay. Expected. Okay, now am I going the right direction everywhere? Cool. Okay, so now I have all of my resolved, or all of my sources that I need. Could be nothing. And anything that was missing is filled in with a constant that just has a 0 in it, which is equivalent to what I was doing on the dynamic side. So that's cool. Now I need to figure out how to build my final resolved edge. And how do I do that? So I had figured out some of that down here. I know that if I think I can just basically do this. Something close to it. Here. Okay, so type expected reference found that. And I want only the second part. And it's already a string. Clone it. No, it's not two strings, right? Because it's not already a string. It's a static stir. It just did this somewhere else. I no longer remember how it is. Is that like that? What do you want? Okay, fine. Okay, so now I have the code for this node. And I am ready to actually construct the final thing. And this is where I build the tree of branches, which is what I was talking about at the beginning of the video, like an hour ago. And that's what I'm going to do next. But first I'm going to, you know what, that's what I'm going to do in the next video. I'm going to stop right now for this. Cool. So that was a rather frustrating hour, but it's over now. Ready for the next one.